Good evening. Maybe I introduce briefly today's speaker, Gento. He was among the first ordinees at Missouri Zen Center, first two done by Katagiri Roshi. So he started earlier and continued practice until I started teaching in Japan. I asked him to give Dharma talks at the Zen Center because his talk is very interesting and instructive with a science background. He was a teacher at the Logan College until he left St. Louis to South Carolina to teach in another institution. So I think his talk will be very interesting. Okay, please go ahead.
Aaron, if I could ask you to allow me to share a screen.
Oh, sure. Yep. Oops.
He should be able to.
Oh, yeah, that's right. I think you can.
Okay. Well, I want to preface my remarks by saying I'm not a neuroscientist. But over the years, I've come to recognize that a lot of what we know to be true from Buddhist practice handed down from the Buddha is being proved more and more by neuroscientists. So I want to talk a little bit about the brain and your brain on meditation. I want to talk really about three different things. One is just a discussion of brain waves and how brain waves are affected by meditation. And then just a little, not really a lesson in neuroanatomy, but we'll identify some key areas of the brain that function in what are called neural networks, but specifically functional networks. And I guess one of the things I want to emphasize throughout is that there's no one part of the brain that does everything. It's a cooperative effort between different areas of the brain and to different degrees. And then we'll talk a little bit about how these how meditation affects some of these areas of the brain, and then more importantly, how it affects some of those executive functions. So brain waves have been understood for quite a long time, really, because the way of measuring them, the electrodes on the scalp, has been around for a long time. Some of the more important functional aspects that we'll talk about only came to light, with functional MRI and PET scanning, which is a way of looking at photon emissions from the brain to see which areas are active during certain activities, and also through neurosurgery. Some of these things are known. And also from evaluation of stroke patients who have lost brain function when an area of the brain can be identified. So we'll start with brain waves, and there are several types, and brain waves actually originate in the cortex at different levels of the cortex for the most part. And many of them are affected by meditation in a positive way. Alpha waves, which are in that frequency about 8 to 10 hertz, and a hertz, of course, is cycles per second, how many times a wave repeats itself in a second. If you're standing on the shore and the waves are coming in at a regular interval, we call that the frequency. Some waves may be higher than others, and that we would call the amplitude. And that's what's affected by meditation, is the amount of activity in certain areas. So alpha waves are associated with relaxation and like a calm alertness. And these are definitely well known to be increased by meditation. Another wave form is called the theta wave, and that's at about 3.5 to 7.5 cycles per second, 3.5 to 7.5 hertz. And those are usually associated with deep relaxation, creativity, intuition, that sort of thing. Um, Theta waves are affected mostly by um, experienced practitioners who have been meditating for some time. And of course, the result would be a sense of peace, mental clarity. Beta waves have a frequency of about 12.5 to 30 hertz. And they are primarily present during alert and active thinking. And the interesting thing about beta waves is they tend to be decreased in activity, decreased in amplitude during meditation, which helps, of course, to help calm and quiet the mind and reduce anxiety and that sort of thing. Then the next type of wave I'd like to mention is a delta wave. That's at about 4 hertz. And that's usually associated with like deep restorative sleep. So, um, for the most part, not affected by meditation unless you fall asleep during meditation, I guess. Um, but once again, in some individuals who've been studied who are advanced, been practicing for a number of years, they seem to be able to maintain quite a degree of awareness even during delta wave states. So it is possible. And in terms of our discussion tonight, is probably the most important brain wave is the gamma wave, which is a much higher frequency. It's at around 25 to 140 hertz. And these are associated with high level functioning, cognitive functions, like problem solving, conscious awareness. And these are heightened during meditation. And they're important because they result in something called long-range synchronization, which means that brain waves from different areas become synchronized with this increased gamma activity. So there's a kind of coordinated activity all the way across the cortex. And this will be important. We'll talk about it a little bit later on because it can create something called brain-to-brain well, we'll talk about that later. So this synchronization, especially in long-term practitioners, um, it it can heighten the ability to solve problems and that sort of thing. Um, what's more important, I think, in in our Buddhist meditation practice is that brain-to-brain synchronization like this can occur between individuals. There have been studies that show that when someone is reading a story aloud to other people, if you compare the brain activity to that individual to the brain activity of the listeners, you find out that their brain patterns, in other words, the areas of activity within their brain has become synchronized. So I think this is one of the things that helps create a sense of oneness with the meditation group. Um, I'd like to then look at some areas of the brain. I guess you can all see this picture of the limbic system. Is that? Yeah. It's not so important to know the parts of it, just to understand that the limbic system is kind of what we would call the more primitive area of the brain. This area of brain goes far back in evolutionary history. It's present long before these large cortical brains developed in species. And in humans, it's more responsible for kind of like vegetative states. The amygdala is really important to our discussion because it's kind of the center of emotions. Um, and I'm sorry. Oh. The pituitary gland is included as part of the limbic system, even though it's an endocrine gland. That is, it secretes substances like hormones, especially growth hormone, sex hormones, um, thyroid stimulating hormone, those kind of things. So it's more involved with body um, physiology, metabolism, but it is part of what's called the neuroendocrine axis. Um, it has an intimate relationship with the nervous system, so it's also included as part of that. Then this is the cortex. The cortex is that large part of the brain above, and it has several lobes, and they all have different functions. And in fact, if we look at this picture, you can see that there are certain areas of the brain that have been mapped out, partly from stimulation of the brain in conscious patients during surgery, um, functional MRI, PET scans, that sort of thing. And when we talk about brain synchronization between people, that's what we're talking about. Different areas that light up with activity, and different activities light up different areas. And this is something we'll talk about a little bit here in terms of function. So the amygdala, as I said, is kind of central for processing emotions, fear, anger, pleasure. The hippocampus is vital for learning, just where new memories are formed, and it's important in spatial navigation. So you can imagine that if the limbic system becomes quiet during meditation, you start to lose some of that sense of separation from your environment. The hypothalamus regulates heartbeat, blood pressure, temperature, that kind of thing, thirst, hunger. And the thalamus is kind of a relay area that sends sensory information to other parts of the brain. And the ways that meditation affect the limbic system are that deep or your mindfulness meditation, which is the kind of meditation we do as opposed to say meta or focused on a meditation focused on object or mandala. Mindfulness meditation decreases activity in the amygdala. So the fear center, stress center becomes quieter. Consistent meditation practice has been found out, interestingly enough, can permanently shrink the amygdala. So meditation definitely affects neuroplasticity. Neurotransmitter levels are affected in the limbic area by meditation. For example, dopamine and serotonin, which are associated with mood, are increased during meditation. And GABA, which is a gamma aminobutyric acid, it's also increased during meditation. It's responsible for increasing a sense of calmness. The cortex then is higher brain function, awareness, communication. So it's responsible for motor movements, speech, hearing, all those kind of things we think of as higher processes. And of course, the cortex becomes quiet during meditation. The parietal lobe is especially important because it gives you that sense of self-boundary. So as meditation quiets the parietal lobe, like I said, you start to lose some of that distinction between inside and outside the self. So having seen all those parts, I want to talk about how they form what are called functional networks. And the first one I want to talk about is this one. And what we're talking about are these areas in purple here, the prefrontal cortex, part of the parietal lobe, some more of the frontal cortex here. This all works, all these areas input and have shared fibers that kind of crisscross all through there. and they form what's called the default modal network. And this is what I think is one of the most important aspects of brain function and meditation. This is the part of the brain that we revert to when we're quiet. And you might think, well, now wait a minute, because it's involved with things like daydreaming and recalling personal memories, is it good that that's the kind of default mode we go into when we're not solving problems or being active? And the answer is, well, it's actually decreased during meditation. And that allows it to communicate better with what's called the central executive network, which is in the cortex. And it's called this because it's kind of the cognitive control network, or the part of the brain, including some of the frontal cortex, the parietal lobe, prefrontal cortex, and it's involved with active problem-solving kinds of activities, decision making, that sort of thing. It's been referred to as the external mind because it is capable of monitoring the default network, the default modal network. So this is a part of the mind. This default modal network is a part of the brain that we revert to in those moments when we're not, actively doing something that requires activity. I'm going to just talk briefly about a study that sort of piqued my interest in all this years and years ago. It was a very simple study. Subjects were fitted with a network of scalp electrodes for EEG, and they were set in front of a panel that had a light on, had some lights on them and buttons underneath the lights. And their instructions were to press the button as soon as they were aware that the light had been turned on. The interesting thing that happened was that the areas of the motor cortex, which would be responsible for the movement of the finger, were several hundred milliseconds ahead of the actual awareness of the light being turned on in the EEG studies, which suggests that it's not just the aware conscious cortex that's responsible for what we do. The cortex, it turns out, is probably more responsible for narrating the whole thing and trying to make sense out of everything we've experienced, rather than actually being responsible for making the decisions, if that makes sense. So while meditation does decrease the activity within this default modal network, this, kind of at-rest part of the brain, it does increase the connectivity between that and the central executive network, the decision-making part. And that means that the brain is more effective at modulating its attention. It's able to notice when the mind is wandering, and then it redirects the activity back to the present moment, which is exactly what we strive for in meditation. So it actually accomplishes a kind of reconfiguration of the brain rather than just a simple increase in activity. And so it provides for improved attention, emotional regulation. It alters all the brain connectivity. And it actually, over a period of time, once again, these connections can become permanent. So it effectively rewires the brain. So I have a few thoughts about all that real quickly. I was hoping to get done a little sooner so you could ask questions, even though, like I said, most likely can't answer most of them. But meditation does create a lot of physiological effects that we've noticed, and that can be demonstrated by available technology now. And I want to emphasize that this is a natural activity. There's nothing magical or supernatural about meditation. It's just a natural activity of the body and mind. But it may not be that these physiological effects are the most important things we experience. I think that Buddhist teaching of anatta, of no permanent self, is completely compatible with scientific description of brain activity. Like a candle flame is a interactive process between heat and the fuel of the melted wax. In the same way as what we call self is an interactive process. It's a dynamic process. It's in constant flux. So it's ephemeral and impermanent. And I guess the question could be raised, we could probably surmise from either direction. Um, Perhaps the brain just creates these states and they're just an elusive mental state in the brain. Or is it possible that maybe reality is just that kind of connected, universal oneness, and in the meditative state, the brain is just better prepared to interpret the external data and demonstrate that. So, which is which, or does it even matter which is which? So that's all I had prepared for. Yeah, just this one more slide. All these green areas here that you see are the central areas that are involved in the central executive network. So, like I said, one of the main things here I wanted to to point out was that there's no spot in the brain that's the self. What we call the self is simply a function of different parts of the brain working together in a cooperative way. You can't have the one without the whole. So I think in that way very much mirrors what the Buddha taught 2.5 millennia ago. Is there anything that I can add or subtract or clarify?
Sure. I have a question. So, usually what you're describing here, there are inevitably going to be, if we're behaving or we're having thoughts, changes in the brain. And also, we know that if our body is becoming more relaxed or something, there'll be changes. There's going to be some neurological mediation of those conscious states. What can you tell us about the conscious states? Because I mean, how many cycles I'm actually doing, I'm not conscious of that. I have the slightest idea.
I'm sorry, there's a lot of noise in there somewhere I can't.
Yeah, so I'm asking, kind of, how do you see that, kind of what we normally care about when we meditate in some sense is the, kind of qualitative changes in consciousness, not changes that we are sure exists as we would be, say, if we hooked up a mathematician and watched him doing a proof, we know there'd be parietal lobe activation. We know if he's talking himself through the proof that there'd be activation in Broca's area. So I mean, but he's not conscious of that. What he's conscious of is the thoughts he's having when he's doing the proof. So I'm wondering, where does this get us if we have these physiological correlates to meditation? And because after all, we're not conscious of the physiology of meditation.
Yeah,
not at that level.
yeah, but as the modal network draws on past memories and
Sure.
helps formulate the sense of self.
Mhm.
When it's better connected with the executive center,
Yeah.
then the conscious mind becomes aware of how that activity is happening. Does that make sense? In other words,
because there is no impression of the self, right? There's a conscious impression. There isn't one.
yeah.
And usually in neuropsych, we worry about, well, what's the binding problem? How do we get all these diverse, kind of neurological happenings and conscious happenings to be counted the happenings for a particular person?
Hmm.
You, me, Rosan, Aaron.
Yeah, I'm not sure if I quite understand the question, but I mean, a lot of it has to do with the gamma wave synchronization
Sure.
and the communication between the parts of the brain. So meditation in that sense facilitates
Yeah.
the overall function of the brain.
Yeah. So that tells us about the good consequences. But suppose,
Hmm,
Dojin, I'm pretty sure, knew nothing of this.
right.
Somebody said, well, in what ways, if any, kind of was this practice defective because it lacked this knowledge?
I'm having a little trouble hearing you, Mike. I'm sorry.
Sure. So if you said, well, Dojin didn't know anything about this,
Hmm.
so in what way is a practitioner worse off? What is the practitioner missing if he doesn't know anything about the science of it?
Oh, nothing. But it's just that science is able to explain it in a way that can be in a factual way, if that makes sense. I mean, yeah, we don't have to understand the physiology of meditation to meditate, right?
Yeah. Or to
But
justify
I guess what I'm saying is that all these activities that we've known are going on for 2,500 years can now be demonstrated scientifically. So we have some kind of rational understanding of why these happen. It doesn't necessarily make you a better meditator to know it, I guess. No.
no, Dojin didn't.
No, I'm sure, and I'm sure the Buddha didn't either.
Correct.
But it's fascinating for us.
Yes, yes, it is.
Yeah.
That's
I mean, to know that we're not imagining what happens to us during meditation, it can be demonstrated scientifically. And it all has to do with electrical activity in the brain. I mean, we're not our brains, we're not our bodies. But at least we have some scientific validity for this notion that the self doesn't exist in any tangible, permanent sort of way. It's just an electronic state of that nanosecond.
So what would you say if Descartes were right and he said, yes, we did find it at the pineal gland?
I would say we wasted a lot of money on research.
Yeah, that's it's very much a demonstration of co-origination, dependent co-origination. I mean, the sum of all the mental activity of the different parts of our brains is integrated, and that integration is completely dependent on the function of all the other parts.
Yeah.
So,
But that'd be true for mathematical problem solving
well, yeah,
or any other interesting.
yeah, but like I say, that's that sort of default state when the brain goes into idle,
Yeah.
when it sort of disconnects from all the cortical activity. The fact is that meditation allows it better communication with other parts of the brain that can evaluate what's going on. That makes sense?
Yeah.
Yeah.
I'm
Which is why in meditation we become aware of our thinking.
Listen, I thought you gave a very lucid account of all this. I was just
Well, good. I hope so. My idea was to try to make it so that you know a grade school student could understand it almost, but maybe not quite.
well, that's why I was able to ask questions.
I was able to track most of it, so that's a good sign.
Yeah, we have different lumps of tissue, and they all do a little bit different thing, and somehow or another it all comes together. There's no one spot that sort of does it all.
If I can
There-
ask, can I ask a
Mhm.
question? What you said about synchronicity between different meditators, that sounded really fascinating.
Yeah.
You think that might at least put a chink in the armor as far as the materialist paradigm of the brain being a self-contained entity in the head and consciousness just being an epiphenomenon.
To me, yes. That's my starting point. You
Mhm.
know, my contention is that when scientists strive, and they've been, think about it, philosophers and scientists for millennia have been trying to figure out how in the world consciousness can be derived from material substance. And I think
Yeah.
after that many thousand years, someone must be beginning to see the light and say, wait a minute, we must be asking the wrong question.
Well, yeah.
To me, the question is, how is material substance created from consciousness?
Well, it's funny we're joking about Descartes, but I think that's where Western philosophy went wrong. Before Descartes, both in the East and West, nobody had any issues with that. It's once he
Mm,
drew the line between consciousness and mental activity on one hand and the material on the other that we just ended up on this winding path towards,
yeah.
you know, science-ism and materialism that's just so prevalent now.
And to be fair, some scientists are beginning to look at that perspective that possibly if we start from the position of consciousness being there, and then somehow or another we evolved this material, or at least we formulate a concept of material substance.
Yeah.
Yeah.
Aldous Huxley, in his book several decades ago, Perennial Philosophy, he described the brain as, or I should say the brain as being a control valve that just basically consciousness comes into the brain and the brain just basically sorts it out and is able to keep
Yeah.
maybe too much of a good thing from making life hard.
Yeah. That very much is the case. Um, there are at least 100 functional areas in the brain. We usually talk about six of these functional networks, like we were talking about tonight. But they're functionally speaking, it's not necessarily analogous. I mean, not necessarily one-on-one with the neuroanatomy of the brain. That there are at least 100 different functional areas of the brain, and most of what the brain does never rises to the level of consciousness.
Hmm.
And that's probably for the best. I mean, what if you had to constantly monitor your digestion consciously, monitor and control your digestion? I mean,
I'd be thinner.
well,
I'd have indigestion.
but if you had to be conscious to control your breathing, you wouldn't be able to sleep, for example. And of course, we got the limbic system to do all that stuff, regulate heart rate and breathing and digestion and all that stuff
To
while
decide,
the
right?
cortex goes to sleep.
Yeah,
I don't know if you've read Bernardo Kastrup. He's an idealist philosopher. The way he looks at the brain is basically a manifestation of the idea of mind as seen from the outside.
Mm,
So that
yeah.
kind of squares with what you're saying towards the end of your
Mhm.
talk.
Yeah.
Then there are people like me that think it's 3 pounds of meat I've never seen.
Yeah. Actually, it's a little gooey.
Yeah, it's really mostly fat,
It's more like Jello, honestly.
correct? And it's reddish.
Um, if you have access to PBS Passport, I think you can stream these programs from Nova. They did 2 episodes on the brain, and they are well worth a couple of hours to sit down and watch. They talk about a lot of this stuff. It's amazing how unconscious we are about most of the brain's activity.
There's something Freud stressed.
I'm sorry?
Freud stressed that.
Oh, yeah. Yeah.
The unconscious is big. Consciousness small. So how did you get interested in this?
Well, actually, that one study I was talking about, I looked at that and said, "What?" The brain pushed the button, and then the cortex said, "Time to press the button." That's when I began to realize, wait a minute, it's not functioning the way we always thought it was functioning. A lot of what the conscious brain does is just pull all this stuff together and fit it into a mold based on past experience, from which it has to draw on the parts of the modal network, the default network. But it creates a kind of narrative story, and that's where the sense of self, I think, gets reinforced. It just makes everything consistent. We have a history, with our memory, a history of activities, and the brain just compares everything that we experience that comes into the conscious level, at least, and fits it into that stream as the best it can.
And
And most of us manage to do that. Some people have a lot of dissonance and can't do that, but
presumably the idea of a self has a lot of what you might call, it has a great cash value if you want to survive in the real world.
yeah. And the Buddha never said that the self isn't real. He just said it's not permanent.
Correct.
It's not separate from any of this other. He was saying basically what we're saying. It's the sum effect of all these neural networks, and the neural networks are just a way of interpreting our sense data. And our sense data tells us that we're this solid object, even though physics tells we're not. The only thing that keeps us from falling through the floor when we're walking through the house is the fact that we have all these powerful intranuclear forces that repel the atoms in our body repel the atoms in the floor. And so even though that we're all mostly space between the particles, we don't fall through because of those strong internuclear forces. But we never interpret it that way on a macro level.
Well, that's because we don't tell the physicist story. We have a different one, which is ordinary.
So we have this story that we're solid objects, when we're actually just a colony of trillions of cells that work together in a harmonious way most of the time till we get sick. And those in turn are just made up of dancing electrons. So but we certainly have created this very strong story about this object here. And so we objectify ourselves the same way we would objectify a candle flame. And we know that a candle flame isn't a thing, but we have a noun, flame, which makes it sound like a solid object. So we can ask the question, where does the flame go when I blow out the candle?
Yeah, we do it, but there are lots of nouns like eddy. Kind of eddies are not things.
Right.
They're processes. I think probably most people could own up that clouds are processes and not things. It's a little harder to believe, say, that my hand is not a thing.
Right. Exactly. Yeah. And that's
process can be very real.
Well, yeah, the process is real.
Process.
It's just constantly in flux,
constantly
dynamic, and that's my understanding. Sensei, I think, is like a proper translation of samsara. It's just flowing.
Rosan, you're on mute. Oh, there you go.
Can you hear?
Yes.
Yes.
Okay. Sara is onomatopoeia or the water flowing shallow stream. Sara, 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 Sara. San means English sing, complete or sum of or complete flow. So it means complete flow, constant flow. We think we don't change, but actually constantly changing everything. But somehow our ideas, language symbolism stays flowing, fluxing over samsara world into some static self, etc.
Yeah, language definitely does that because most languages have nouns and verbs, and so as soon as you assign a name to something,
processes.
yeah.
Yeah, so language is really tricky. It's a very good tool, but also very dangerous tool. We constantly think with language, symbol, and then we are caught by the symbol like self, state, etc. That's a problem. A meditation can disclose or see more in detail, more subtle points, how our mind works and language works, etc. Okay, I think we are 15 minutes past. So maybe for today we finish and maybe we have other chances. Okay, thank you for joining and hosting. Thank you, and speaker, thank you.
Very much.